Dr. A. Kalpana, Associate Professor of Chemistry, Sri Sharda College for Women in Organic Chemistry. Now let us see about three reactions: Norrish Type II reaction, Paterno-Buchi reaction, and Photoreduction of Ketones. First we can see about Norrish Type II reaction. Ketones that possess gamma hydrogen in presence of light undergo N2 pi star transition to singlet, or in triplet state it forms biradical first. That is, cleavage of homolytic cleavage of C double bond O takes place in presence of light in singlet excited state or a triplet excited state, and there will be a formation of biradical. Then there will be a transfer of gamma hydrogen from gamma carbon to oxygen radical. Then there will be a formation of 1,4 biradical. This 1,4 biradical will form product in two pathways, pathway 1 and pathway 2. In pathway 1, ring closure will occur and there will be a formation of cyclobutanol. In pathway 2, there will be a cleavage of beta bond and there will be a formation of alkenol and alkene. This step, that is 1,4 biradical, undergoes cleavage of beta bond to form alkenol, and alkene is called as Norrish Type II reaction. This particular step is called as Norrish Type II reaction. So once again I repeat: ketones that possess gamma hydrogen, ketones that possess gamma hydrogen, alpha, beta, gamma hydrogen, in presence of light forms a biradical. How it is forming the biradical? First there will occur a homolytic cleavage of carbon-oxygen bond. So here one electron will come, oxygen one electron will come. In carbon there will be one electron and in oxygen there will be another electron. Therefore, this is due to homolytic cleavage of C double bond O. There is a formation of biradical. Then there occur a gamma hydrogen transfer. That is, this bond will cleave and there will be a radical in this carbon and H dot will be formed. This H dot get transferred from this carbon to oxygen and there will be a formation of another biradical. Two pathways are there to form products. Pathway 1 means ring closure. Just these two electrons connect to form a bond and ring closure will occur. In pathway 2, there is a cleavage of this bond. This beta bond will get cleaved. Alpha beta bond will get cleaved. This carbon will have one electron. This carbon will have one electron. Then there will be a formation of alkene. This part will be formed as alkene and this part will be formed as alkenol. This step is called as Norrish Type II reaction. This Norrish Type II reaction occurs both in singlet excited state and in triplet excited state of N2 pi star transition, and the yield will be greater if the reaction occurs in triplet state when compared to singlet state. Therefore, yield from singlet state will be less when compared to triplet state. In case of aryl alkyl ketones, the reaction occurs with triplet state because aromatic ketones undergo rapid intersystem crossing from singlet excited state to triplet excited state. But first the reactant in presence of light get excited to singlet excited state, that is S1. Then usually these aromatic ketones rapidly undergo intersystem crossing from S1 to T1, and from T1 the reaction will proceed and there will be a formation of product. Coming to solvent effect, polar solvent has no effect on singlet state reactions. That means polar solvent, if the reaction is carried out in polar solvent, there is no increase in rate of the reaction if the reaction occurs at singlet excited state. If the reaction occurs at triplet excited state in presence of polar solvent, the rate of the reaction will be increased. In absence of polar solvent, we can measure the rate of the reaction. In presence of polar solvent, we can measure the rate of the reaction. The rate of the reaction will be greater in presence of polar solvent if the reaction is carried out if the reaction takes place in triplet excited state. So polar solvent has no effect on singlet excited state reactions, and polar solvent enhance the rate of the reaction in triplet state reactions. And participation of 1,4 biradical intermediate is confirmed by trapping experiments and spectroscopic techniques. Now, what is the proof that gamma hydrogen transfer to oxygen atom is intramolecular? So, for this fact, we are taking an example. We are taking a ketone that possesses gamma hydrogen. For the same substrate, we are replacing the hydrogen with deuterium. So, we are taking a normal substrate and the same substrate as deuterated one. A normal ketone and a deuterated ketone. Both the ketones are same ketones, just a hydrogen is replaced by deuterium. We are taking these two substrate, and these two substrate are subjected to Norrish Type II reaction in presence of light. So what will happen in presence of light? First, the CO bond will undergo homolytic cleavage to form a biradical. Then gamma hydrogen will get transferred here, and there will be, this is formed from substrate 1. And in substrate 2 also, first there occur homolytic cleavage of CO bond, and there will be a formation of biradical. Then this deuterium that is present in gamma carbon will get transferred from gamma carbon to oxygen, and this biradical is formed. 1,4 biradical, 1,4 biradical. Once again I am saying, first this ketone CO bond will undergo homolytic cleavage, and there will be a formation of C dot and O dot. And the hydrogen that is present in gamma carbon will get transferred, and this bond will get cleaved, and this H dot is transferred from carbon to oxygen, and this carbon will now have one radical dot, C dot. This is 1,4 biradical formed from this substrate 1. And this substrate 2, similarly C double bond O bond get cleaved homolytically, and therefore this carbon will have one electron, this oxygen will have one electron, and the deuterium carbon bond will also get cleaved. Gamma carbon will have one electron and deuterium will have one electron. This will get transferred from carbon to oxygen, and this 1,4 biradical will be formed. This 1,4 biradical will give individual product, one alkene and alkenol. This biradical will form another alkene and alkenol. There is no crossover products. Separate products is formed. Formation of these products confirms that transfer of hydrogen takes place from gamma carbon, and also the process is intramolecular because there is no crossover products. Only individual products from individual biradical is formed. And next one is, what happens if two gamma carbons both having hydrogen is present in a single substrate? What will happen when a molecule has two gamma carbons both having hydrogens? Means what will happen? Let us take one example. See here, we are taking ketone. With respect to this ketone, this is alpha carbon, this is beta carbon, and there are two gamma carbons. Gamma carbon 1, gamma carbon 2. Gamma carbon 1 is having 3 hydrogens. Gamma carbon 2 is having 1 hydrogen. Which hydrogen will get transferred to oxygen? Is the weaker CH bond will get cleaved preferably, and that hydrogen will get transferred easily to CO, that is easily to oxygen. In first step, in presence of light, this CO bond will get homolytically cleaved, and there will be a formation of biradical, that is carbon will have one electron and oxygen will have another electron. In the second step, gamma carbon hydrogen bond will get cleaved. In pathway 1, this gamma 1 carbon and hydrogen bond will get cleaved, and H dot will get transferred to oxygen in pathway 1. In pathway 2, this gamma carbon 2 that possesses hydrogen, this bond will get cleaved, and this hydrogen H dot will get transferred to the O dot. That is pathway 2. So in pathway 1 there is 1,4 biradical, in pathway 2 there is another 1,4 biradical. This 1,4 biradical will further undergo alpha beta bond cleavage, and there will be a formation of an alkene and alkenol. In pathway 2 also similarly, this alpha beta bond will get cleaved, and there will be a formation of an alkene and alkenol. When we compare the yield of these two mixture of products, this mixture is having higher yield and this one is having lower yield. That is, these are the minor products and these are the major products. So, the presence of major products and minor products prove that the weaker CH bond get cleaved and that hydrogen, that H dot will get transferred to O dot. So, when a molecule has two gamma carbons both having hydrogen, weaker CH bond will get cleaved preferably and that H dot will get transferred to the O dot and there will be a formation of 1,4 biradical which subsequently give two products, that is alkene and alkenol. That's all about Norrish Type II reaction. Once again I say, Norrish Type II reaction, the substrate is ketone that possess gamma hydrogen. Ketones that possess gamma hydrogen in presence of light undergo N2 pi star transition. The reaction will occur at singlet excited state or in triplet excited state. The first step is the cleavage of homolytic cleavage of CO bond and there will be a formation of C dot and O dot. In the next follow to that, there will be a cleavage of gamma carbon with the hydrogen bond. That bond will get cleaved and H dot will get transferred to O dot and there will be a formation of another 1,4 biradical. This 1,4 biradical, as it is ring closure will occur, means cyclobutanol will be formed. That is not related to Norrish Type II. In another pathway, that is this alpha beta bond get cleaved and there will be a formation of alkenone and alkene. This cleavage of bond on this step is called as Norrish Type II reaction. So next we are going to see about Paterno-Buchi reaction. Addition of carbonyl compounds to alkene to form oxytanes is called as Paterno-Buchi reaction. In Norrish Type II reaction, there is only one substrate, that is ketone containing gamma hydrogen. In Paterno-Buchi reaction, there are two substrates. One is carbonyl compound, the other one is ketone. Both get added together and the product will be formed. The product is called as oxytane. So, what is the product called in Paterno-Buchi? Oxytane. What are all the substrates we are taking in Paterno-Buchi? Carbonyl compound, alkene. Two substrates we are taking. Now let us see one example. Here the carbonyl compound, for carbonyl carbon we are taking benzophenone substrate. For alkene we are taking isobutene. Both will add to each other in presence of sunlight and forms oxytane with higher 90% yield. This reaction is called as Paterno-Buchi reaction. So once again, what is Paterno-Buchi reaction? We are taking two substrates. One is carbonyl compound, the other one is alkene. Both add to each other and form a product which is called as oxytane. Very simple. Two reactant, one product. What are all the two reactant? Carbonyl compound, alkene. What is the product called as oxytane? What happens here? Addition reaction. Just carbonyl compound adds with alkene. Just an addition reaction. The alkene we are taking may be electron rich alkene or electron deficient alkene. Let us see about that. Addition to electron rich alkene. First we are taking a carbonyl compound, that is, let us take a ketone here. In presence of light, it will go to a singlet excited state, then intersystem process and forms triplet excited state. There occurs a cleavage of CO bond. C will have one electron, oxygen will have another electron, a biradical will be formed. To that biradical only alkene will get added. In alkene, carbon-carbon double bond, one bond will get cleaved, homolytically cleaved, and carbon 1 will have one electron, carbon 2 will have another electron. So there are two biradicals. What are they? Ketone is one biradical. This alkene will have one biradical. Here C dot O dot, here C dot C dot. So addition may occur directly. That is, directly it can add, or this alkene may get added inversely. Inversely also it can add. If there is a direct addition, that is carbon 1 to oxygen and carbon 2 to carbon, means this oxytane will be formed, that is having higher yield of 90%. If carbon 1 is added to this carbon and carbon 2 is added to oxygen, means that is inverse addition, means the addition oxytane is formed and it is having a lower yield of 10%. So direct addition 90% oxytane is formed. Invert addition means 10% oxytane is formed. Next one is addition to electron deficient alkene. What is the alkene we are taking? The alkene is having CN groups, which is electron withdrawing group. Therefore, the alkene is called as electron deficient alkene. Here we are taking both cis alkene and trans alkene, and we are taking acetone, that is ketone. This first in presence of sunlight, this C double bond O will get cleaved homolytically, and this carbon will have one electron, oxygen will have one electron. Similarly, in alkene, if this carbon-carbon bond is broken, means homolytically cleaved, means this carbon 1 will have one electron, carbon 2 will have one electron. Just we are giving a direct addition in presence of a light, there will be a formation of oxytane. In trans also similarly, CO bond will get cleaved first, so we will get C dot O dot. This carbon-carbon bond will get cleaved homolytically, so we get C dot C dot. Direct addition in presence of light, we will have as oxytane. See here, the cis cyanide is retained in, the configuration is retained in oxytane also. Here, see here, cyanide are cis with each other. Cyanide groups are cis with each other. Here we can see cyanide groups, two cyanide groups are trans to each other. This indicates that the stereochemistry is retained in the product also. The reaction is stereospecific reaction, and the stereochemistry of the alkene is retained in the product acetane. Oxytanes are formed only from singlet excited state with the N to pi star transition. The oxytane formation takes place via exemplex, that is, the ketone will be in singlet excited state. Ketone will be in singlet excited state. First, the homolytic cleavage will occur. Carbon will have one electron, oxygen will have one electron. This biradical will be in singlet excited state, and the alkene will be in ground state. Both will form a complex called as exemplex. One substrate is in singlet excited state, another substrate is in ground state. Both the substrate will add to each other and form a complex called as exemplex. Through the exemplex only, the product will be formed. What is the product? Oxytane. Next we can see about intramolecular Paterno-Buchi reaction. What is intramolecular? What is Paterno-Buchi? First, Paterno-Buchi means there will be two substrates. One is carbonyl compound, another one is alkene. What is the product called as? Oxytane. In presence of light only, this reaction will occur. It is a photochemical reaction. What is intramolecular Paterno-Buchi? The two substrate is present in, two functional group is present in a same substrate. What are the functional group we need for Paterno-Buchi? One should be carbonyl compound, another should be alkene. The two functional group, carbonyl function and alkene function, is present in same compound, means it will undergo intramolecular Paterno-Buchi reaction. So it is given by gamma delta enones. See here in this substrate we can see alkene functional and also carbonyl ketone functional here. So first, in presence of light, the ketone, that is CO bond, will get cleaved homolytically. Homolytic cleavage occurs between CO bond, and oxygen will have one electron, carbon will have one electron, biradical will be formed. In next step, this the C double bond C, one carbon will get cleaved homolytically, so this carbon will have one electron, the neighboring carbon will have another electron. There will be addition and formation of oxytane. So both ketone functional group and alkene functional group is present in same substrate. The reaction efficiency depends on the rate of the interaction between excited CO group on ground state C double bond C group. The yields are high, generally high, and generally there will be no byproduct. So Paterno-Buchi, intramolecular Paterno-Buchi, always the product will have higher yield, since there are no byproducts or no competitive reactions. And the reaction is highly efficient, versatile method for the synthesis of variety of compounds. This is a versatile method. This intramolecular Paterno-Buchi reaction is a versatile method for synthesizing variety of compounds. So once again we can revise what is Paterno-Buchi. There should be two. One is carbonyl compound, the other one is alkene. In presence of sunlight, the reaction will occur. What is the product called as oxetane? The last reaction is photoreduction of ketones. Photoreduction of ketones. We are taking ketone here. Let us take benzophenone. Another one is benzhydrol. What is the role of this benzhydrol? It will act as an hydrogen donor. To get ketone reduced. In presence of sunlight, the reaction will occur. Therefore, it is called as photoreduction. In presence of sunlight, the reduction will occur. Therefore, the reaction is called as photoreduction. So, we are seeing now photoreduction of ketones. What are all the substrate? Ketone. If we take benzophenone means we are taking benzhydrol to donate hydrogen. What is the product called as benzphenacol? See here, C double bond O is reduced to COH. Now let us see about the mechanism. First step, in presence of light, N to pi star transition, the reactant goes to singlet excited state. Then it crosses to triplet excited state. See here, singlet excited state. It intersystem crosses to triplet excited state. There the cleavage occurs. C double bond O, bond get cleaved homolytically. Homolytic cleavage of CO occurs. C will get one electron. Carbon will get one electron. Oxygen will get one electron. There the substrate is in triplet excited state. There comes another substrate, that is hydrogen donor, that is benzhydrol. It donates hydrogen to this O. Then there will be a formation of the product called as benzphenacol. Just two radicals will be formed. They add to each other and form a product called as benzphenacol. Ketones undergo photoreduction in presence of variety of hydrogen donors other than secondary alcohols. Variety of hydrogen donors, the ketone will undergo photoreduction reactions with variety of hydrogen donors. Hydrogen abstraction is more efficient for N to pi star than pi to pi star for ketones. And excited ketones can be reduced by tertiary amines also. So I gave an example here. See, we are taking ketone. In presence of sunlight, it goes to singlet excited state, then intersystem process and goes to triplet excited state through N to pi star transition, and there occurs a C bond O cleavage, homolytic cleavage of C bond O. C dot and O dot will be formed. To that O dot, then tertiary nitrogen will donate electrons. Therefore, the ketone get reduced and forms ketyl radical. Two ketyl radical add to each other and form a product, phenocols. Phenocols will be formed. Phenocol will be formed. So, thank you. So, now in this video, we have seen three reactions: Norrish Type II reaction, Paterno-Buchi reaction, and photoreduction of ketones. Thank you.